Alright, so the game plan today. Sloan has told me that the fourth blockers may not be aware that there's actually a test today. There is. So what I will do then is let you choose to take your test either today or Monday. I think most of y'all are going to choose to wait until Monday to study a little bit. So today we're going to go over the quiz first, the solo quiz. I saw some good things, I saw some not good things on there. Area, y'all are doing better on. Volume, you're still having a little trouble with that. I don't know why this is so difficult, because these are the kind of problems where I honestly think you should be banking 9 points on these on the AP. They're really that straightforward. And it's the same kind of question over and over again. Again, think finish line. Yes, this test is kind of important for your grade, but the AP test is way more important than that. So just have it all done by the time the AP rolls around. All right, let's get started then. Do I? Should have been
Stupid.
Yeah, it kind of was. I was like, why'd you do that? You knew that. We've done it in class.
It's literally, I've done it like 2 other times in this paper. The next
By the way,
question.
number four. But we have done that very problem
I don't know
in
why.
class together. It should be in your notes verbatim.
I don't know why I did it.
All right, number 1. 1, 2, and 3 are all about area. Area between curves. So in general, when you're doing area between curves, your formula is going to be from A to B. Notice there is no pi. Don't start slapping pi's on areas because that's not a rotation of any kind. Top function minus bottom function. If there is a switchover at some point, dx or dy, whatever, if there is a switchover at some point, you'll need to find that spot and then do 2 separate integrals where it switches over. Or, if it's a calculator question, slap the absolute value on it and you should be fine regardless of which order you put it in, okay? You could also do, we could change this equation to do like this. If it happens to be turned sideways. If we're going y values, then we would do right minus left, which is technically the top and bottom for your y numbers, or your x numbers. All right, so this is the model for us. Number 1, you have the curve y equals x squared. You have y equals 0. And you have x equals -1 and 2. Hello.
What happened to all the chairs? Are we losing more every day?
I think they pushed that one out of the ways. Oh, wait a minute.
There's one there, there's one there. Or 2 there. I think there's an
Do
extra one back
you
here.
want the country rollers you over there?
Now I'll play with it. I think there's an
Nice.
extra one back there.
Yeah.
That's what it is.
If you are
I don't know, it's
curious about what the shape looks like, you don't have to know this. In your head, I would probably be decent at it.
Man, I thought I did better.
I was just,
Could have been worse. Alright, so here's our good old parabola, y equals x squared. Here is y equals 0, which is the x-axis, and then we've got from -1 to +2. So all of this area is above the x-axis. We don't need to worry about any of it being negative. Nothing crosses over. There is a spot where it almost did, but we always have the parabola on top and we always have the line on bottom. So the area for this one is going to be from -1 to 2, that's where our zone goes, -1 to 2, of the parabola. You could put the bottom function, which is 0, but doing a -0 doesn't really help or hurt anything in that problem. So there's the setup. And this is definitely one where I would have gotten my +1 for doing it by hand, because it is super easy. Antiderivative is going to be 1/3 x cubed from -1 to 2. There weren't that many people that decided to do that, by the way. Stick in 2, we're going to get 8/3 minus, this is a mistake one person made, top minus bottom, so, or I'm sorry, yeah, top value minus bottom value. Stick in 2, you get 8/3 minus, when you stick in -1, you get -1/3, so it technically is +1/3, not -1/3. That is 9/3 or 3. calculator would have given you the exact same answer.
Yeah.
So that was a nice light, welcome to the quiz kind of question, you know, get your points while you can. Number 2, and then I went completely off the rails, because number 2 was not pleasant. Y squared equals x, and the line x plus y equals 2.
Fine.
Those of you that tried to do this one with the x stuff, that's where you ran into trouble because you were doing the wrong zones. If you actually switched this over to y, it was a cakewalk. So here's the picture of what's going on. You have,
Sideways parabola.
this is sideways parabola, a right-facing parabola like this. And x plus y equals 2 looks something like this.
I wrote down my answer for this one,
Okay.
and I was
That's
proud of
pretty
myself.
crap.
So the zone you're looking for is there. If you did this one x-wise, you have issues. You have zone number 1, which would be the top half of the parabola minus the bottom half of the parabola to wherever that spot is. The second zone would be line on top, bottom parabola, a bottom root on bottom, going from whatever that point is to whatever that point is. The easier way to do this would be to look at it in a y direction and think of this as top and think of this as bottom. That way you have the line always on top and the parabola always on bottom, which means we need to change everything to y. They were nice enough to actually start you in y. This one is not that hard to solve. You get x equals 2 minus y. So my area is going to be the top minus the bottom. Okay, I have more parentheses than I need, but it doesn't really hurt anything there. The only other question is, what is the interval? Where do we go from and to? And it's not this interval, it is this interval. So I need to know where the line and the parabola meet y-wise, not x, but y. So maybe do a little scratch work and
Fine intersections.
find out where y squared equals 2 minus y. I bring everything over, y squared plus y minus 2 equals 0. That factors into y plus 2 and y minus 1. So we get y is equal to negative 2 and 1, so those are my intervals right there, negative 2 to 1. I'm not going to bother showing you how to set this one up with x, because I honestly think it's easier to do it this way and you should be that slick. I think, don't quote me on this, but I think if you did x's, you would need to do one from 0 to 1, and then from 1 to 4. I think that's where the other one is it 4?
Yeah, that one is at 4.
With those two zones there.
Is
but I
that
like this
literally
better.
the one time?
Or, once you had changed it, you could use the calculator. You could also use the calculator with x's, but I like this better. So we get 2y minus, pardon me, 1/2 y squared minus 1/3 y cubed from negative 2 to 1. Okie dokie, here we go. Stick in 1, that's easy. We get 2 minus 1/2 minus 1/3. Stick in negative 2, okay. Negative 4. Negative 2 is going to give me positive 4 divided by 2, so minus 2, I think. And then negative 2 gives me positive 8/3. Okay. This works out quite nicely. This is negative 6, but because of that negative, it becomes positive 6. That positive 6 and that positive 2 give me 8. All right, so hold that thought. That takes care of you, and you. This is a negative 1/3 and a negative 8/3, which is negative 9/3 or negative 3. Takes care of you and you. And then minus 1/2. So we get 5 minus 1/2, which is 4.5 or 9/2. Oh, one other thing, on the calculator, I know I harp about 3 decimal places, but there are no 3 decimal places. If you do the decimal, you get 4.5, that's fine. If there aren't extra decimals, you don't need to put them. If
So 4.5.
4.5 is perfectly fine because that's where the decimal actually terminates. Yep, that's what you wrote, 4.5.
I had that comment on something.
Well, it goes like it goes a while longer than, oh, that's what
Okay.
the calculator said.
Right, you know why your calculator said that?
Because it was probably a little bit off.
Well, his calculator said 4.50000, it did a few zeros and then it had some other
It
decimals.
had like 1.2.
Yeah, well, whatever,
One,
but it
two.
went like a good chunk of zeros and
Yeah.
then did some other stuff. If the answer is 4.5, why is the calculator giving me something like,
Because it's not actually doing,
yeah, it doesn't know how to do an integral, what's it doing to find area?
It is
Just trying.
All the rectangles, it's doing like 100 rectangles, so it's coming really close, and for it, when I see this number in the calculator, I'm like, 4.5, yeah, okay.
I don't think I got that. I think I just got 4.5.
You can also change it by, a number of things you could do is tell the calculator to stop at 3 decimals. You know how to change the decimal setting?
yeah.
Okay. You can also change your increment. Right now, I think the calculator does steps of like 0.1 or 0.01. You could set it smaller than that, like 0.001, if you really wanted to become way more accurate. You just need to let your calculator sit and crunch for a little while. Because the more increments you give it, the longer it's gonna take to calculate. All right, there's number 2.
Before I forget, Jeannie wanted me to tell you something.
All right.
She wanted you to be the bad guy and tell Miss Lyden that she can't get out of 4th.
I know we talked about that yesterday.
Yeah. But she's really serious about it.
I know. I'll tell her we got a really important lesson today, so I've been practicing my, no, you can't, no,
Yeah.
no, you can't ever. All right, there's number 2. Any questions on how we set it up? All
I
right, good.
messed up.
Number 3. Yeah, that one was not a fan favorite. That one a lot of people didn't do great on.
I tried.
I liked it.
Number 2 or number 3?
3.
Oh, 3 I thought was great. 2 was not a fan favorite. 3 was not that
I like
bad at
both.
all. Y is equal to 2 over x
Got
and x plus y equals 3. Okay, you don't need to graph these, but for the sake of understanding what we're doing, I think it's nice to see a picture of the graph. So, here's what this would have looked like. X plus y equals 3 is going to cut through like this. And 2 over x looks something like this and this. This part of the graph honestly doesn't concern me at all, okay? It's this tiny sliver right here that I'm concerned with. So, from the picture, or from the graph, or whatever you did, it is clear that the line's gonna be on top and the little crescent there is gonna be on the bottom. You have choices, no matter whether you go top to bottom or right to left, you always have one on top. So I would suggest let's leave it in X's and just do top to bottom. But I need to know, for the sake of the interval, where they meet, okay? So I'll do that first this time, figure out where they meet. So I'll set 2 over x equal to, if I solve that, I get y equals 3 minus x. So where does 2 over x equal 3 minus x? Multiply by x, and you get 2 equals 3x minus x squared. I'm going to bring these two guys over to this side, so x squared minus 3x plus 2 equals 0. That factors into negative 2 and negative 1. So I get x equals 1 and 2. So it's a tiny window, from 1 to 2, and that's it. Makes sense there. So let's see, the area is going to be the integral from 1 to 2. Top function is going to be the line, so 3 minus x. Bottom function is going to be the hyperbola, 2 over x. The x, and if you're a calculator junkie, type it in, get your answer. Okay, so I think it's 0.1137 or 114 if you round it, something like that.
Yeah, I got 4.4.
Okay, if you do this one by hand, really not a bad one at all. 3x minus 1/2 x squared. You should recognize that as a natural log with a 2 up front, so it's going to be minus 2 natural log of x. I should technically have an absolute value, but I don't need it in this problem because the numbers I'm plugging in are already positive, so it doesn't bother me. All right, let's stick in 2. We're going to get 6 minus 2 natural log of 2. Stick in 1, we get 3 minus a half minus 2 natural log of 1. Natural log of 1 is 0, so that's gone. You have 6 minus 2, which is 4. 4 minus 3 is 1. 1 plus a half is 1 1/2 or 3/2. That leaves this one, the minus 2 natural log of 2. And without a calculator, there is my answer. Okay, with the calculator, you get 0.114. Are there any questions on the first 3, the area stuff? Again, y'all have seen, I
I
think.
just need 5, that's.
Yeah, we're getting there. The, making a reference to your quest, the ones y'all just turned in, there were 2 on this quest that, there were 2? Anyway, you had an area volume in there somewhere too, and there was area volume.
I think it was like the first one.
And somewhere else in there, 3rd or 4th one. Usually the very first question they ask you is area. And the second question they ask you is maybe something with volume or maybe
I think it
something
was
with the
volume.
answer. So it's usually like an area, volume kind of setup, for the most part. I think, yeah, the quest was area, volume of rotation, and then.
It was like, oh, it was the equals, the K equals.
That's the, yeah,
That's so-
I was like, I know I've seen that one somewhere, that's such a cool problem.
And
That
I'm
was,
like,
I
and then
saw
I
it, was
looked at it, I'm like, oh, this is,
wasn't
and I
it
actually did it, I'm like, oh,
Clovis
this.
telling us about, so thanks to you, it's probably the only reason I.
Yeah, we got that one.
And it was so
I don't
cool because it
remember.
was just like, I did it, I'm like,
I
oh,
just
this is so
remember him saying there's
cool.
something about one
Completely
that
different
has
shape,
a
it's
K
got
in
the
it,
same
and it'd be a
volume.
neat idea for me, and all you do is just plug in K to the equation, and then you just put it up.
Like one's just
And
like
it
this
didn't
little.
say solve, so.
One of them looks
Oh, I
like the
should've done
cylinder
that.
on the
I didn't do
outside
it.
with this
Dang it.
weird hyperbola cut out of the inside, and the other one looks like a tire on the outside with a cylinder cut out of the center.
Well, hopefully I got the other parts right.
Yeah. Okay, we're gonna clear the slate then and do volume. We'll do it in 2 pieces. 4 and 5 were cross sections, and 6 and 7 were rotations.
I guess I just don't know cross
Yeah,
sections.
true.
Those are the ones I get wrong
Well,
each time.
Cooey number 4.
yeah.
I don't know what it is now. Can I stop reading?
Okay. So let's talk cross sections.
Please do, because I'm lost on this.
Okay. The way they set up a cross section problem, remember, is to take some area, and that's, I need this, and that's gonna be the base of some solid, and then from that base, they'll grow the solid out of it. And the shapes will all be the same, no matter how you slice it, it's just different sizes based on what the boundaries were for the base. The formula is, with a volume, go from A to B of whatever the area of a slice looks like. So if they say the slices are squares, then this is gonna be the equation of a square. If they say the slices are triangles or semicircles or whatever, then you need to know the area of that particular shape. Areas you may want to know: square, side square, rectangle, length times width, triangle, 1/2 base times height. We're about to write all that down. Let's see, what else do they like to do? Circles?
Yeah.
Circles.
Yeah,
Circles.
is simply circles.
That's gonna be pi r squared. If they say semicircles, which I think they did on number
Yeah.
4, then you take half of that. Okay, so these are your geometry formulas. They could actually ask you anything they want, but these are the typical ones I've seen. I love this one, this one, this one. Now the triangle can be kind of tricky. It's, 1/2 base times height, but the way they orient the triangles can get you all kinds of screwed up, because equilateral versus right isosceles are two completely different setups. All right, let's do number 4. So here's our base. Base for this figure is the equation y equals sine of x from 0 to pi. And that's it. Oh, and the x-axis. Okay, so lop it off at the bottom. And cross sections are going to be semicircles with the diameter on the base.
So there was a cross section on the quest, right? Because I'm pretty sure I got that wrong.
Yeah.
Yeah.
Then I'm pretty sure I got that wrong.
There was one, yeah. One,
Yeah.
It wanted squares.
How about
It
this
wanted,
square?
it wanted rectangles with 5, with the height 5 times the length.
Oh yeah, that's a good one. That's a really good one.
So it's really just
Yeah.
It's
5
like-
feet square.
remember
It's,
seeing it.
it's width times 5 width or something like that.
Which is really just
It's
5
width
width
squared, yeah, when you do that. It would have made it even more cool if the width actually turned out to be something with a root in it, then they cancel each other out, and you're.
Damn.
Yeah. Let's see, semicircles, okay. Okay, if you wanna see a picture, you're talking about, and I'll go ahead and lay it, if that bothers you, then tough. You got your sine function or one little piece of the sine function, so it's gonna keep on curving and doing that, and that piece is gonna go that way, whatever. We're only looking at it from 0 to pi, so that's our base area. And then we're gonna take and slice it and put semicircles in there. Okay? So, I need to start with the area of a semicircle. Well, we know that the circle is pi r squared, so the semicircle is gonna be 1/2 pi r squared. Okay? We therefore need to know what the radius is. Those of you that put sine, that's the diameter. The radius is half of that. Okay? So the radius for us is going to be half of this distance, which is half of sine. Everybody cool with the setup there? A lot of y'all forgot this 1/2 right here, so your answers, I think, were like 4 times as big as they needed to be. Okay, so if we plug this in, we get the area of a slice is going to be 1/2 pi times 1/2 sine x squared. And if you clean that up, that's a 4th, so you get pi 8 sine squared x. Or you could just type all that in the way it goes. So our volume is going to be pi 8 sine squared x. The interval they gave you was from 0 to pi, like so. Now, this is technically one you can do by hand. However, you can't do it if it's written like sine squared. You have to use one of your trig formulas to rewrite this as 1 minus 2 cosine over 2. I do not think many of y'all have that memorized. So most of you would have taken this, plugged it into the calculator, and gotten, wait for it, 0.6168,
What
yada, yada,
were we
yada.
supposed to change it into if we were doing it by hand?
If you were doing it by hand, you would need to know this formula, or this identity. This is what we call one of our power reducers. It gets you from a square to a not square. Because I can do the antiderivative cosine, and then I would have taken this and split it into a 1/2 minus cosine x, like that, and then go on from there. Your answer, even if you do it this way, is gonna be something with pi's in it. I don't know that it's gonna work out that nicely, or, I'm sorry, roots of something, 3/2, or some mess like that. So there you go. Yep. Actually, I think we need the antiderivative. This turns into sine, and sine with zeros and pi's is fantastic. So So it's like pi 8 times a half. All right, ta-da! That's if we do this one the right way. Most of y'all that knew what you were doing forgot the 1/2. You just did the diameter of it instead of doing the radius of it, and that's what killed a lot of your numbers. If you got an answer that was somewhere in the neighborhood of like 3.2, that was kind of what you did, is you forgot that thing. I'm sorry, 2.4 and some change-ish. That was you forgetting the 1/2 in front, assuming you did everything else correctly. All right, then the number 5. Oh man, did I throw all the mean stuff I could think of at you on number 5. Evil, evil Mr. Floyd. All right, number 5. Here's our base. Where are we? Okay, y equals e to the x. Already exciting. Y equals 1. And x equals natural log of 3. Cross sections perpendicular to the y-axis are squares. So cross sections, y-axis are squares. Okie dokie. Let's see what we got here. Okay. Down. All right, here's y equals 1. Here is x equals natural log of 3. It's vertical lines somewhere out in the ether. X equals natural log of 3. Y equals e to the x is going to be our exponential function, doing something like that. All of this you could have gotten by looking at your graph if you didn't know what these look like, but you should know what exponential functions look like. So the zone we're looking at is right here. That's our base. Cross section is perpendicular to the x-axis, so the y-axis. So I'm going to slice it this way to make squares. Actually, they'll come up like this. They'll look like squares when they come up. Okay. Big one, so on and so forth. So immediately, I know I'm going to have to turn everything into y stuff. Immediately, because we're going y-axis, and we can't use shell on this because we're not actually spinning it. So the first thing I would have done is turn this into x equals natural log of y. Just take the natural log of both sides to get that. Okie dokie. So let's see here. My volume, area of a square is side squared. So all I need to know is the length of a side. Well, that's pretty simple. Right minus left, which is the equivalent of top minus bottom. The right is fixed at natural log of 3. The left is moving, but it's this, natural log of y. So we're going to have natural log of 3 minus natural log of y. So there is the length of one side, so side squared. This is the area of one slice. Everybody kosher? Mazel tov. All right, so the volume will be the antiderivative of natural log of 3 minus
I'm
natural
not
log.
kosher.
Huh?
I'm not kosher. I was never blessed.
We need an interval. Again, we're doing y values here. I think it's pretty easy to see that we're going to start at 1. This is where the y's actually start. So the question is, where does it stop? That's also easy. If x is equal to natural log of 3, if you plug that back here for x, e to the natural log of 3, the e and the natural log cancel each other out, you just get 3. Okay, so these went from 1 to 3. They gave you a nice number like this for that very reason. All right, this you can do. That's just a number. So the antiderivative of that part would just be natural log of 3 times y, whatever. This is a BC one, we can't take the antiderivative of the natural log, we don't have to do that one yet.
Do you have to square it now? You
Oh,
don't square it?
you're right, thank you.
Okay.
Alright, so that makes it even worse, because then we'd have to distribute it out, and it would give us not only a natural log, but a natural log squared, so that would be hideous. Yeah, calculator for you guys. Calculator's gonna spit out, wait for it, drum roll please, 0.5958 and some change. Okay, and I'm giving you more than the 3 decimal places, just so you see. I think one person rounded or truncated it to 595, a couple of y'all rounded it to 596, those that got it right. Okay, which wasn't very many. Don't freak out about the Y's, they're not gonna kill you. Okay, any questions on these two? Did that get what you needed for this one?
Yeah, I see now.
How about the rest of us? Feel pretty good about that one? Because that one really was the breaking point for a lot of people. Y'all got to this one and went, nope, I'm done. And I think even though 6 and 7 weren't hard, y'all were still reeling for number 5, so you couldn't quite recover and get it together. That's cross sections, one type of volume. The second type of volume is rotations. Same premise. We're going to find the area of one slice. Then we're gonna add them all up. The difference is each of those slices happens to be the exact same shape, circles, okay? Or in the case of washer, circles with circles missing. All right, so let's clear the slate and look at rotational. I don't even think I gave you a shell one on this one. I did not. Okay. And I'm gonna say at this point, if you know shell, great. If you don't know shell, it will not kill you on the test, you'll just have to suffer through changing stuff into Y. You got a little time to, I mean, you got until 2 months-ish to learn it. Alright, 6. So for this, we've got pi r squared. For washer, some of y'all write it as 2 separate integrals, which is perfectly fine. I tend to write it as 1. You do big R squared minus little r squared. Some of you, like I said, are a little, not confused, but a little leery of actually subtracting first versus squaring first. We square first and then subtract. So you split it into 2 separate discs, which is absolutely fine.
I think I do that.
If it saves you the heartache of, am I doing it right, then by all means, do that. So for number 6, we have, I will write this in case anybody feels like using it ever. 2 pi r h. Okay, if that still is not quite clear to you, then I would say scrap it at this point. Just focus on the ones that make sense to you.